Hello, this is Jack Jackson. In this video, we're going to be talking a little bit about how to estimate the derivative at a particular point from a graph of the function. We're going to do this using this GeoGebra application that I have written, and this is freely available at GeoGebra's website. And this is the applet, estimating the derivative point of a graph. And it gives you the directions down below. And so we recall that the geometric meaning of the derivative of a function at a point is the slope of the tangent line at that point. So they're going to look at this two different ways. And one way is we're going to use this line here to approximate the tangent line. So here we have a function that we type in, so you can type in your own formula, whatever you want there. Choose the place that you want, choose your point, and you can actually do it a couple of different ways. You can do it by moving this point along the curve to wherever it is you want to be. You can do it by the slider, which will move that point along. Or you can actually just type in a specific number, for example, 0 here, or let's say we do it at maybe 0.5. So if you want it to go to a specific place exactly there. Okay, so let's see if we can figure out what the derivative is, and we're going to do this two different ways. So the first method we're going to do is to find the derivative is we're going to try to make this a tangent line. Now remember, the tangent line goes through that point of tangency, but it needs to kind of follow along the curve there. Okay, so we can move this around, and somewhere in this vicinity we can pick it. So we change it by moving this point B. Okay, so let's do the best we can. Oh, maybe is that it? Okay, so say if that's it, now we want to find the slope of this particular line. Okay, now to do that, we're going to need to find a couple of points on that line that where it's crossing one of our little grid lines if we can. Looks like there's one there, about there, that looks like that's 0.1 and 2. And then find another point on there where it goes through a grid line. This one looks like it's pretty close. 1.5, negative 1.1. So let's look at that. And the point that we have here is, so let's do it this way. So it looks like these are 2 points on the graph that we just came up with. Now we just simply use the slope formula to work this out. Recall that the slope formula, m, is delta y divided by delta x. That's y2 minus y1 divided by x2 minus x1. This is x1, y1. This one's x2, y2. Simply plug in those numbers, and then we work this out. In the top, we do this subtraction. At the bottom as well, we get negative 3.1 for the numerator, and we get positive 1.4 for the denominator. That means delta y is negative 3.1. So we went down 3.1 units, and delta x is 1.4, so we went to the right 1.4 units. Multiplying top and bottom by 10, that's negative 31 over 14, or as we see here in the calculator, about negative 2.21. So that's our estimate that we came up with there. And I'm going to put that in here in this box, negative 2.21. All right, so that's method 1. Okay, method 2 is to use a symmetric difference quotient. So the symmetric difference quotient, you remember, is just to use the slope formula, but instead of trying to find a tangent line and do the slope from that, what we're going to do is we're going to do the slope from 2 points nearby to this point A, one to the left and one to the right, equally spaced left and right. So what we're going to do here is maybe go we could go to this major grid line here at 0 and see that that's 2, and then this one at 1 here when we go to the right. So we know that this way of doing it works out like this. So here we're using a h of 1/2 or 0.5. We're going to the half either side, half a unit. And so that's h is 0.5, and those 2 points were 0, 2, and 1. Sorry about that. Using that point, those 2 points, we work out the slope formula like this. Again, it's still the same thing, delta y over delta x, or y2 minus y1, or x2 minus x1. But in this case, it's 0 minus 2 over 1 minus 0, and we get -2. If you wanted, we could get even closer here and maybe do this minor grid line here and see what we have. We have to estimate what's going on here and here. So this would be a smaller h. In theory, that's better. In practice, it may get too hard to read the graph. Okay, but let me get this thing out of the way so we can just look at the blue graph. So if we went to the left here, went to this grid line, of course we know that's 0.4, and then the corresponding y. Now we have to estimate that. Well, let's see, this is 1, 1.1, 1.2, 1.3, 1.3 something. I'm going to say about 1.34. Okay, so that is the point. Let's see, what was that? That was the point 0.4, and then 1.34 for y. And then go the same amount to the right would put us on this little bitty grid line, and that's 0.6 for the x, and the y is about, looks like 0.9. Okay, so that gives us those 2 points, and that's when h is 0.1. So working that out, we get for h is 0.1, we saw that the graph goes through the points 0.4 and 1.34 to the best of our abilities, and 0.6 and 0.9 for the other point. Then do the slope. 0.9 minus 1.34 is -0.44. And 0.6 minus 0.4 is 0.2. Divide that out, that's -2.2. So we have some different estimates here. Of these two, we would expect the smaller h to be the better value, so -2.2. Notice that's pretty close to what we got here when we did it with the tangent line method. So I'm going to go ahead and put in -2.2 as my second estimate. Now let's check our answer. So let me put this back where we had the tangent line drawn, and let's see how close we were. I don't know if that's exactly where I had it before, but let's see what that looks like. And here's checking our answer. There's the tangent line. I'm off a little bit, but not terribly bad. That would be better there. See, and so the slope of the line I had was well, we estimated it to be -2.21, but I've moved it around since then, so I don't know if I had it in the same place. So notice that the the applet here gives you the slope of the line that you have, even if it's, you know, like way off, or hopefully you did it pretty close. It'll tell you what the slope of that is, rounded off to that many places. That agrees with what we had up here. So one thing you could do is check to see if you got the slope correct for the line that you drew. You can check that against that number, with our estimate. And then this is the slope. This is the difference quotient with 0.05 here or 0.5 here. And I think I may go back and edit this to where it gives you the difference quotient with the smaller h as well to see. But then you can compare both of these numbers, or both of our numbers here, to the actual value, which is negative 2.25. We did a pretty good job with that either way. So you can practice with this by changing the formula, changing where A is, and experiment a little bit with it. So notice that the let's see, A was 0.5 before, and you can see the 2 points that we used for the symmetric difference quotient there for the first estimate that we did. And then you can see the I think I'm going to go ahead and add 2 more for this closer estimate. So anyway, that gives you an idea of how to practice and how to visualize this with this particular app. And you can practice this as much as you'd like till you get comfortable with doing this type of a problem. I hope this helps you out some.